Good afternoon and welcome to part 2 of the C4, the quantitative chemistry topic. Now I don't want you to watch this video and get started on this work unless you're confident on the content from the first video. So if you can't remember what AR and MR are, then go back and have a quick watch before you attempt this. Okay then. In everyday English, we use the word dozen all the time, and we know that that means 12. And we use baker's dozen to mean 13. So why am I telling you that? Well, in chemistry, we have a word to represent a number, and that word is the Avogadro constant, and it represents quite a large number. An Avogadro constant is 6.02 times 10 to the power of 23, which we can write like that. Now, I prefer to write it in standard form because otherwise I get a bit confused by the zeros. Now, the Avogadro constant is simply the number of atoms or molecules or ions in 1 mole of a substance. So the number of atoms in 1 mole of a substance is 6.02 times 10 to the power of 23. Now, 1 mole of any substance is its relative formula mass, its MR, in grams. Okay. Before we carry on with that, I'm just going to tell you, this is my favourite abbreviation in all of chemistry. So we're going to be talking about moles. So moles is written as mole. Now we always abbreviate to give us units. The units for moles are mole. Okay? So we might talk about 1 mole or 2 mole or 3 moles of something, and that's the abbreviation for moles. Okay, so when I'm writing this, I haven't just spelt it wrong. It is the abbreviation for this one. I know, it's a little bit daft. Okay, so it has an equation. So the number of moles is the mass in grams divided by either the AR or the MR. So it's the same equation. Number of moles is the mass divided by the AR, or number of moles is the mass divided by the MR. Okay, now this is going to make far more sense if we have a go at a question. So, how many moles of sulfuric acid, H2SO4, molecules are there in 19.6 grams of sulfuric acid? So how many moles of sulfuric acid molecules are there in 19.6 grams of sulfuric acid? So we need to write the equation before we start. Now, do I need this equation or this equation? You're right, I need this equation because this is an MR. So, number of moles equals mass divided by MR. Okay, now I know my mass is 19.6. I'm going to substitute that in. Ooh, now I need to work out the MR. So my MR is H2SO4. So I've got 2 H's, got 1 S, and I've got 4 O's. Okay, I'm going to have a quick look at the periodic table. Okay, now I know that I needed H, which has a mass of 1. For sulfur, it's there. It has a mass of 32. And oxygen is 16. So, I've got 2 times 1, which is 2. 1 times 32, which is 32. And 4 times 16, which is 64. So then I add these together, which gives me 98. Okay, now that 98, I'm going to put in over here. So I've got 19.6 divided by 98. I use my calculator, which gives me 0.20. My units are moles. Now, why have I put this 0 here? the information here okay, so we're happy with that answer. Well done. Now let's have a go at a different one. Okay, this time the question's slightly different. What is the mass of 7.5 times 10 to the power of minus 3 moles of aluminium sulfate? And aluminium sulfate is Al2SO4 3. Okay, now we know we're going to need to work out our MR. So let's work out the MR first. MR of Al2SO4 3. So I've got 2 ALs because there's a 2 after it. Now I've got a bracket. And brackets make things a little bit trickier. So this number multiplies everything inside the brackets by 3. So I've got 1S because there's no number after it. And 1 times 3 is 3. So I've really got 3 S's. I've got 4 O's, but 4 times 3 is 12, so I've got 12 O's. Okay, now we're going to need to look at the periodic table again. So aluminium is 27, sulfur is 32, and oxygen is 16. So I've got 2 times that to 27. I've got 3 times 32. And I've got 12 times the 16. Okay. So you have a go at working those out. So did you get to 342? If you did, well done. Now, the equation I gave you a few minutes ago said number of moles equals mass divided by MR. Now this time we need to work out the mass. So using our skills from maths, we know that we need to move this. So if I multiply this side by MR, they'll cancel out. And I'll have mass equals MR times the number of moles. So mass equals the number of moles times the MR. Now we need to substitute some numbers in here. Mass is what we're trying to work out. MR, we've just worked out over here. Number of moles. What is the mass of 7.5 times 10 to the power of minus 3 moles? So I need to type in here, right in here, 7.5 times 10 to the minus 3 multiplied by 342. Okay, and that comes to 2.6 grams. Now I want you to use that worked example and have a go at the first section of questions, that's questions 3 and 4, part 1 on the second worksheet. So have a go at part 1 of the second worksheet. Okay, we've got an equation here, and this equation isn't balanced. If you're not very confident at balancing equations, have a look at the balancing equations video and worksheet before you have a go at this, because being able to balance equations is really important for this next chunk of work. Okay, if you can't balance equations, you're going to really struggle. So go and do that one before you carry on with this, unless you're really confident already, and then fabulous. Okay, it's got this equation. I've got 2 hydrogens and 2 chlorines reacting to make hydrochloric acid, HCl. Now, I've got 2 hydrogens and 2 chlorines, so I must have 2 hydrogens and 2 chlorines over here. Now, we usually talk about this being 2 molecules of hydrogen and 2 molecules of chlorine reacting to make 2 molecules of our hydrochloric acid. No, it doesn't have to mean that. So over here, I don't have a number and I don't have a number here, which means it's those imaginary number 1s that chemists just don't write because we're a bit too lazy. Now we have the same in front of here. In front of this, we could write a number, just like we have a number 2 here. And that number would be 1, and that's why we don't write it. And that 1 could mean 1 mole of hydrogen and 1 mole of chlorine react to make 2 moles of our hydrogen chloride or our hydrochloric acid. Let's have a look at this question. So what masses of reactants and products are involved in the balanced symbol equation? So we have our equation. It's asking us what masses of reactants and products are involved. Okay, so these are my reactants. And I need to find out what mass they are. And these are my products. I can use the equation mass equals moles times mR that we just did. So, how many moles of hydrogen are there? Well, there's 1. So for hydrogen, it'll be 1 times the mR for hydrogen, and the mR for hydrogen is 2. So 1 times 2 is 2 grams. Let's look at the mass of the chlorine. How many moles? Well, there's no number there, so it must be 1. And the mR of chlorine, oh, let's have a look. There's chlorine, 35.5. 35.5. But there's 2 of them. So 35.5 times by 2 is 71. And 1 times 71 is 71 grams. Okay. The mass of the hydrogen chloride or the hydrochloric acid. How many moles do we have? We've got a number here this time, so we have 2 moles. So we have 2. This is 35.5 and this is 1. So we've got 2 times 36.5, and 2 times 36.5 is 73 grams. So all we've done is we've used this equation, mass equals moles times mR. We learned how to do the mR calculations in the last video, and moles is the number at the beginning. And if there's no number there, it's 1. Okay, the question. Chlorine gas is bubbled through a solution of sodium hydroxide to make bleach. If you have a solution containing 100 grams of sodium hydroxide, what mass of chlorine gas do you need to convert it to bleach? Let's read that again. Chlorine gas is bubbled through a solution of sodium hydroxide to make bleach. If you have a solution containing 100 grams of sodium hydroxide, what mass of chlorine gas do you need to convert it to bleach? And we have our balanced equation. Okay, the first thing I'd like you to do, I'd like you to work out the mR of the sodium hydroxide and the chlorine, please. Okay, now did you get 40 and 71, or did you get 80? If you got 80, don't worry about it. When we calculate the mR, we ignore these numbers at the beginning. We're just worried about the actual equation. So we're worried about this bit, not this bit. So the mR of the sodium hydroxide is 40 and the mR of the chlorine is 71. Now we know that the mass of this is 100 grams, and this is the mass that we're trying to work out. Okay, now, if we've got mass and we've got MR, you already know an equation that you could do to work something out. And you're right, that's moles. So let's do moles equals mass divided by MR. So that's 100 divided by 40. And that's 2.5 moles. So this is saying I've got 2.5 moles. But here in the question, I've got 2 moles. So I need to look at the ratio. So here in this equation, I'd have a ratio of 2 to 1. I'd have 2 to 1. But I don't have 2. Really, I have 2.5. So I need to work out what this missing number would be. Okay, now I know that you can do this from maths, that you can do converting your ratios. So I would do 2.5 divided by 2 would give me 1.25 mole. Okay, now I know that my MR for the chlorine is 71, and I now know how many moles of chlorine I've got. So if I know the MR and I know the number of moles, then I can work out the mass. Because mass, as we did earlier, mass is moles times MR. I've got 1.25 moles and an MR of 71. And 1.25 times 71 is, have you worked it out? 88.75 grams. And that's our answer. So all we've done is we've put together different pieces using that same simple equation, just using it in slightly different ways with a ratio thrown in. Now, I have a method that I like to use. Okay. And it's EMMA. So E, write a balanced equation. M, work out your moles. The next M, work out your molar ratio. And then A, work out your answer. So my mnemonic to help me to remember how to do a calculation is EMMA. E, write a balanced equation. M, calculate my moles. Next M, work out my molar ratio. And A, calculate my final answer. So there's my mnemonic. EMMA. E, balanced equation. M, calculate your moles. M, find your molar ratio. And A, calculate your answer. Now I want you to have a go at the worksheet 2, part 2 questions. Okay, next question. Sodium nitrate, NaNO3, decomposes on heating to give sodium nitrite, NaNO2, and oxygen gas, O2. When 8.5 grams of sodium nitrate is heated in a test tube until its mass is constant, 6.9 grams of sodium nitrite is produced. What mass of oxygen gas is given off? And find the ratio of reactants and products involved in the reaction. Show how these can be used to produce a balanced symbol equation. Okay, now we know that any time we do any reaction, the mass of reactants, so the mass of the things we had at the beginning, is exactly the same as the mass of the product, the things we've got at the end, because of the law of conservation of mass. So we know that the sodium nitrate was 8.5 grams. So we know that 8.5 grams is going to equal the sodium nitrite plus the oxygen. Okay, and I've put oxygen down as X just because I know that you'll then find this really simple. 8.5 grams is equal to 6.9 grams plus X. So tell me what X is. Have a go. Okay, did you get to 1.6 grams? Well done, I'm impressed. Okay, now the second part of the question has asked us to find the ratio of reactants and products involved in the reaction. Now to find that ratio, we're going to need to calculate the MRs. So if you can calculate the MR of the sodium nitrate, which is NaNO3, the MR of the sodium nitrite, which is NaNO2, and the MR of the oxygen, which is O2. Have a go at those. Did you get these values? 85, 69 and 32. If you did, well done. If not, go back and have a look at your working out. Doesn't matter if you're making a mistake. What's really important is you trying to work out where you went wrong. Because we all learn by making mistakes. But in order to improve, we have to work out where the mistake is. So if you've made a mistake, go back and have a look. Now, we've got our MRs and we need to work out our molar ratio. So to work out a molar ratio, we need to work out the number of moles. So moles equals mass divided by MR. Now you know the masses, you know your MRs, so have a calculate of the moles. Give it a try. Okay, so you should have 0.1 mole, 0.1 mole and 0.05 mole. So our ratio is 0.1 to 0.1 to 0.05. Now we don't want all of these decimals, do we? So if we divide them all by the smallest number, so if you divide 0.05 by 0.05, you'll get 1. If you divide 0.1 by 0.05, you'll get 2 and 2. Now what we need to do is use those numbers to write a balanced equation. So I'm sure that you can already tell me the first part, which is the sodium nitrate makes the sodium nitrite and oxygen. Now all we have to do is put these numbers in. So that's a 2, that's a 2, and this is a 1. And that's our answer. So 2 sodium nitrate reacts with 2 moles of... No, that was me making a mistake, isn't it? So what did I say earlier? If you make a mistake, you have to go back and correct it. So 2 moles of sodium nitrate decomposes to make 2 moles of sodium nitrite and 1 mole of oxygen gas. Now I want you to have a go at the part 3 questions on the worksheet. Okay, the next question. If you have 4.8 grams of magnesium ribbon reacting in a dilute hydrochloric acid solution containing 7.3 grams of HCl, which reactant is the limiting reactant? Now, the limiting reactant is simply the reactant that's used up first. So let's imagine I've been baking and I'm baking chocolate cakes. But I've only bought enough chocolate to make 5 chocolate cakes and I want to make 10 cakes. The limiting reactant for me to make chocolate cakes is the chocolate. I don't have enough chocolate to make 10 chocolate cakes. Now, in this question, we need to work out which one is the limiting reactant. Okay, now we're going to go back to using that mnemonic, remember, to help us do a calculation. We're going to start with the E. So I want you to pause, I want you to have a go at writing the equation. Okay, so our equation, magnesium plus 2 HCl makes MgCl2 plus H2. Now I'm going to write down what I already know before I go any further, because to me, going back to the question all the time can confuse me. And especially in an exam, I can get really muddled. So I like to write down what I need from the question, so I don't have to keep going back to that really wordy thing at the beginning, okay? So if you have 4.8 grams of magnesium ribbon, I'm going to write the word mass here. I'm going to write 4.8 grams underneath my magnesium. I'm going to try and keep things in nice columns. So 4.8 grams of magnesium ribbon reacting in a dilute hydrochloric acid solution containing 7.3 grams of hydrochloric acid. So I've got 7.3 grams. Okay. Now I always have to calculate the MR. So pause me and have a go at calculating the MR of just these two. Okay, did you get 24 and 36.5? Of course you did, because you're getting really good at this. Now, we need to work out the moles. So you know that moles equals mass over MR. So calculate the moles of the magnesium and the moles of the hydrochloric acid. Did you get 0.2 for both of them? If you did, well done, that's fantastic. Now, up here in my equation, I've got a ratio of 1 to 2. But here I've got a ratio of 0.2 to 0.2. So, which one did I not have enough of? So if I need twice as much of this as this, then if I'd got 0.2 here, then this would need to say, you're right, 0.4. So my limiting reactant is the hydrochloric acid. I need 0.4 moles of it, but I only have 0.2. So I'm going to write that as my answer. Okay, so I've written my answer in words, and I've written the limiting reactant is hydrochloric acid because 0.4 moles is needed to react with the 0.2 moles of magnesium, and we only have 0.2 moles of the HCl. Okay, have a go at the part 4 questions. Well done. Well done. That is this entire topic finished. My advice would be go back, have another go, read through your questions, and then I'd like you to try the last section, the part 5 questions that I've left for you. So have a try with the part 5 questions. Remember, all your working out needs to be shown, and use that mnemonic, use the EMMA, balanced equation, calculate your moles, calculate your molar ratio, and then work out the answer. Give them a go. Let me know how you get on.